Okay. So if I'm having, dear students, if I'm having sodium chloride, okay, so this was we have done in the previous class that I'm going to revise this one more time. For example, if I'm having camera is not on, okay. Now, for example, if I'm having sodium, okay, so sodium is going to have electronic configuration 281, okay, and that of chlorine is 287. You know that the nearest noble gas for sodium is, what is the nearest noble gas for sodium?
Neon.
Neon, and that is going to have stable electron configuration of 2,8. And the nearest noble gas for chlorine is argon, and the electronic configuration for argon is 288. So what does sodium want? Sodium wants the electronic configuration to the nearest noble gas, that is neon. And what does chlorine wants? Chlorine wants the stable electronic configuration to that of argon, that is 288. So what actually sodium has to do in order to attain the stable electronic configuration to the nearest noble gas, that is neon? What sodium has to do? Tell me. Tell me what
Sodium has to lose
do
one electron.
So it has to lose one electron. Only the electrons that are present in the outermost shells need to participate in the bonding. So this is sodium, 1 electron, and this is chlorine, 7 electrons. So what sodium is going to do? Sodium is going to donate one of its electron to it. So it will become Na positive because it has donated one of its electron. So when electron is being donated, it gives positive charge. And similarly, the chlorine get 1 electron from sodium. Okay. Then what would happen? Chlorine is going to get 1 negative charge. Why? Because it has got 1 extra electron from sodium. Okay. Now these are tightly bonded together with a strong electrostatic force of attraction. They are going to form ionic bond. Okay. So what would happen after donation? Sodium. This is the first step that we need to represent while drawing the Lewis dot structure. Okay, this was just explanation. So this is the first step. This is the first step, and this is after donation. This is the second step. Okay, or this is the second step, and the third step is just to make them Na positive like this way, and chloride. The third step. Okay, so this is the structure for the sodium chloride that we have done in the previous classes. Now let's move to the next topic, that is not the next topic. We should discuss some other questions, some other Lewis dot structure that is being asked in the examination. For example, if I'm asking to draw the structure of magnesium chloride, okay, and magnesium, let's draw the structure of magnesium chloride. Second one is calcium chloride. Third one is aluminium oxide, Al2O3. So let's do these. So if I'm having magnesium, so magnesium is going to have atomic number 12. The electronic configuration of magnesium would be, tell me what would be the electronic configuration? 282. Very good. 282. So how many electrons are there in the outermost shell of magnesium?
2.
Okay. And that of chlorine is, the formula for magnesium chloride is MgCl2.
MgCl2, yeah.
So there is two chlorine atoms present here. Okay. If there are 2 chlorine atoms, you can put it like this way. This is your choice, or you can put it like this way. It's your choice. Okay. Is my voice is lagging, or is it clear, 100% clear?
Sir, it's clear.
So now moving to this portion here, you see that here is chlorine atom, 1 chlorine atom here, 1 chlorine atom. Here we have put it. Both are going to have 7 electrons. And let's put this magnesium atoms, magnesium electron here. So one is going to donate to this way, to this one, and one is going to donate to this one. What is going to happen now? After donation, what would happen? What is going to happen? Okay. Tell me what is going to happen. Magnesium will acquire what? How much charge is magnesium going to acquire?
2 plus.
2 plus, because it has donated 2 electrons.
2 electrons, yes.
Okay. And magnesium is going to have, sorry, chlorine is going to have how many electrons? 8. Because it has gone 1 extra electron, so it has acquired 1 extra electron.
1 minus.
1 minus. And here also. Okay. So this is the second step. This is the first step. This is the second step. And the third step, what we need to do here is the third step, we have to write here AMG 2 positive, and then Cl, make these electrons 1, 2, 3, 4, 5, 6, 7, 8, minus 1. And then we have to write here 2. Got it?
Yes, sir.
Please note it. Note it down. Done. I'm going to check the copy after the class, whether you are writing or not. Okay. So I will check on camera whether you are writing or not. So please write down each and everything that I'm writing. Okay.
Sir, in the last step, why don't we write Mg2 plus in the bracket?
Oh, beta, I forgot this one. Yes, yes, yes. We have to write here 2 plus.
Okay, okay, sir. Done, sir.
Other students? Faiz? You done?
No, sir,
Shoaib?
all done.
Jobita done?
Yes, sir.
Yes, sir, done.
Done. Okay. Let's next step. Let's do next step. That is Al2O3. Al2O3. They are the 2 aluminum atoms and 3 oxygen atoms here are present. Okay. So how many? What is the electronic configuration of aluminum?
13, 283.
283. And that of oxygen? That of oxygen? The electronic configuration of oxygen?
26.
2,6. Oxygen is going to have 2,6 electronic configuration, and that of aluminum is 283. So what aluminum is going to do for attaining the stable electronic configuration?
Lose 3 electrons.
It has to lose 3 electrons. Okay. And what oxygen is going to do in order to attain
It
stable
will gain
electronic
2.
configuration? It will gain 2. So aluminum has to lose 3. So I'm drawing here 3. Okay. Because its outermost shell electrons is 3. And here oxygen is going to have 6 electrons in its outermost shell. So 1 electron here and 1 electron. Okay. 2 electrons. Now this 1 electron here from here, this is also 1 electron is being shared. That 2 remaining to this one and to this one. Got it? Got it?
Yes, sir.
And what we are going to do here is, this is aluminum. The 2 aluminum atoms are present, so we have to write 2Al. But you can write the next after the sharing of this one, you will get Al 3 positive. The second step is after showing.
Good evening, sir.
Good evening, Beta. How are you?
Sir, fine.
Why are you late?
Actually, sir, I was not at my room. I was outside and I hurried up for the class.
Okay. So you now understood?
Sorry, sir.
No, Beta. I'm just asking the other students.
Yes, sir. Understood, sir.
Take out your copy and start doing. Okay. We are just studying the ionic structures. So this after donation of the electrons, this will become +3. Okay. Understood. And this after attaining the electrons, they will get -2. So this is the first step. This is the second step, and the third step is you have to write here Al 3 positive. How many atoms are there of Al? There are 2. So write 2. And then oxygen. How many oxygen atoms are there of O2 minus? There are 3. Right here. Got it? Please note it down. So this ionic structure is whenever it is being asked to draw this structure, and what you need to do here is that you need to complete this process in 3 steps. Okay, got it? Should I move? Let
Done,
me
sir.
know when you have done. Other students still doing?
Done, sir.
Okay.
Done, sir.
I will check your copy after the class. Okay, so please, every students must notice this one, that they have to make the proper diagram of this one and write each and everything proper thinking. So these are the generally asked questions. Others you can also draw. So let me help you. Have you done the chemical properties of non-metal? Check. Have you done the chemical properties of non-metals? I think we have done. Check whether we have done or not.
No, sir. We have only done of metals. Chemical properties of metals.
Okay, let's move to the next portion. Yes. Now there are some conceptual questions we need to ask. Okay. So here it is. The first one is chemical properties of non-metal. Chemical properties of non-metals. So first is this, you have studied that acids when react with metals, your metals when react with acids. You see that metals when react with acids, what they form? They form salt plus hydrogen gas. Salt plus hydrogen gas. Similarly, metals when react with, let me give you example. For example, Zn when react with H2SO4, it will give you ZnSO4 plus hydrogen gas. Similarly, metals when react with base, they also form salt plus hydrogen gas. If I'm asking this question that, okay, for example, if I'm making zinc when react with NaOH, it will give you Na2ZnO2. That is called sodium zincate plus hydrogen gas. Got it? Got it?
Yes, sir.
So let me ask one important thing here is, do non-metals react with acids? Like the metals are reacting with acids. Do non-metals also react with acids to liberate out hydrogen gas? Do non-metals also react with acids to produce hydrogen gas, to produce hydrogen gas? Tell me, beta. You think?
No, sir.
No. So let me explain you this one. Okay. For example, if you are having this, what is going to happen when acid react with metals? For example, this is zinc, and this is placed in the solution of H2SO4. This is zinc, and it is placed in the H2SO4 solution, aqueous in water. So what is going to happen when H2SO4 is present in the solution? It is going to be in the form of H positive and SO4 minus 2 ion. Got it? Got it? Means they are in the form of aqueous. Whenever acid is present in aqueous, it is in the form of, for example, if I'm having HCl acid, then it will be in the form of H positive and Cl minus. They will be here, H plus ion and Cl minus ion will be moving here and there. Okay, this is H positive, Cl minus, H positive, Cl minus. Okay, so if it is H2SO4, then it will be H positive, SO4 minus 2, SO4 minus 2, like this way. Got it?
Yes,
Got
sir.
it? What is going to happen when zinc is reacting? Zinc will donate 2 of its electron, one to this one, one to this one. And when H plus ions get 1 electron, it forms hydrogen atom with no charge. Similarly, H another one get one electron, it will again form hydrogen atoms, and these two combine together and form hydrogen gas. So how it become possible? It become possible when there is someone present in the solution that is providing electron to these H plus ions of acids to form hydrogen atoms, and these hydrogen atoms combine together to form hydrogen gas. Got it?
Yes,
Got
sir.
it? But what would happen if there is no zinc? Means no metal donor, no electron donor. So if there is no electron, for example, sulfur is going to have electronic configuration 286. 286. So it's already need 2 electrons to complete its octet, to complete to have the electronic configuration to the nearest noble gas. So if it is 2 here, then what is going to happen here is, tell me, what is this one is 6. Okay, so when this 6 is being reacted, so it will not be able to donate the electron because it is non-metals are electron deficient. They don't lose the electron, they gain the electron. Got it? Got it? Sulfur 286, when it gives 2 electron, it forms sulfur -2 and it is sulfide ion. Like chlorine 287, it gain 1 electron and forms Cl- ion 288. So if I'm saying that non-metals are not electron donors, but metals are electron donors. You see, metals are electron donor. So if zinc is providing here, other one is so there is metals. Metal is providing the electron to this H plus ion of acids, and that is converting, when after getting the electron, these H plus ion converted into hydrogen atoms, and hydrogen atoms get combined together, they form hydrogen gas. But non-metals are electron deficient. They are not able to give electron to this H plus ions of acids to form hydrogen atoms and to give them to produce hydrogen gas. Got it? So for the production of hydrogen gas, what happens actually? The H plus ions of acid get electrons. These are the, where do we get H plus ions? From acids. From acid we get these. Okay. So the H plus ions from acid get electrons, and who is the electron donator? Metals. Metals are electron donator. Metals are electron donator. Got it? Got it? Everybody understood? Metals are electron donator. They are electron rich. They donate electron. For example, 281 sodium, lose 1 electron. For example, 282 magnesium, lose 2 electron. For example, 288 calcium, lose 2 electrons. Okay, so metals are electron donator. They generally aluminium 283, it lose 3 electrons. So they are electron donator. And non-metals are electron acceptor. So they are not going to, if we react with acid like having HCl, and it react with sulfur, it will not form HCl2 plus hydrogen gas. No, it will not form. Why? Because sulfur don't give the electron to the H plus ions to form hydrogen gas. Electron donator, sulfur is non-metal, and sulfur do not provide the H plus ions, electron to the H plus ions of acids. It will not provide electron to the acid. So non-metals do not react with. That's why we kept the acid in the non-metals. We kept acid in non-metallic container, container. Okay, because they don't react with acid. Okay, got it? Got it?
Yes, sir. Got it.
Understood. So moving to this one point is that we are having this question, and in the chemistry, if electron is added to someone, if electron is added, for example, if I'm having Zn plus HCl, it gives you ZnCl2 plus hydrogen gas. Okay. So if I'm having Zn plus HCl, gives you ZnCl2 plus hydrogen gas. What is going to happen here is that zinc is providing, if we balance this equation, you can balance this one, 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. So zinc is providing 2 electrons to the 2 HCl. If we have 2 HCl means H positive, Cl minus, Cl minus. So zinc is H positive, Cl minus, Cl minus. So zinc is providing 1 electron to this one, 1 electron to this one, and they combine together, they form hydrogen atoms and form hydrogen gas. But in zinc chloride and zinc, when donated electron, it becomes Zn2 positive. And chloride Cl minus ions are already there. So this will form ZnCl2 that we have studied in this structure, how ZnCl2 will form. So in the similar way, in case of non-metals, they will not. Okay, and addition of electron is called addition of electron. Zinc is adding electron to the H plus ion, so it is called reduction. In chemistry, we call it reduction. Reduction means addition of electron. Addition of electrons. So So if I'm saying that zinc non-metals are not able to reduce H plus ions of acid to form hydrogen atom and subsequently hydrogen gas and subsequently hydrogen gas. I'm just writing in rough. I'm just going to explain you this one. If I'm saying non-metals are not able to reduce means, what is the one word reduce means here? Means add electron, or you can say donate electrons. So if I'm saying that this substance is not able to reduce in chemistry, it means that it is not able to add electron to that substance. Got it?
Yes,
Got it?
sir.
Everybody understood? I'm only listening the
Yes,
voice
sir.
of only one student. Do anyone here who wants to have
So
some dart?
understood.
Do you know what is the meaning of dart? Dart padna in Hindi?
Yes, sir.
I think you all must be familiar because you're all parents. All of your parents are Indians, na? That's why I'm just saying. So dart पड़ जाएगी बेटा अगर नहीं जवाब दिया तो. Okay, got it. So let it be. So if the questions arises from you that why do non-metals do not react with acid to liberate hydrogen gas? So non-metals are not able to produce hydrogen gas on reaction with acid because non-metals are electron deficient. They are electron deficient. They are not electron rich. They have the electron. For example, sulfur has 286. They have the electron, but they are not able to donate. They are 6. If any element is going to have 6, then it is not going to donate. It is going to accept 2 electron. It will not donate electrons. So they are called, that's why they are called electron deficient. The non-metals are called electron deficient. They are not able to reduce H plus ions of acids to hydrogen atoms. H plus ions of acid to form hydrogen atom by donating electron to form hydrogen gas. Okay. While metals are electron donating in nature, they can easily donate electron to the H plus ions of acids to form hydrogen atoms and thereby hydrogen gas. Got it? So please note it down. Note it down fast.
Certain.
Show me in on the camera. Please show me.
Yes, sir.
Please show me on the camera. Wait a minute. Video is not complete. Okay, show me beta. Yes.
So it is not showing the reverse camera.
Okay, show it from the front camera.
Yes, sir. So is it visible?
No, it is not visible. Nobody can look at this. Okay, after the class, I'm going to ask you the screenshot of this one. Okay, but sorry, screenshot
Sure,
means
sir.
photograph.
Sure,
Okay? But because we are just studying online, then I need to be very serious because if I think that you are doing something wrong, then I need to check it because these teachers are the mirror image. We can see that mirror image of a teacher can be seen in his student. Okay, so if I'm teaching you in a good manners, and if I'm teaching, I'm keeping proper eye on you whether you are doing correct, whether you are studying or not. So it's a quality of me. Okay, so if anybody wants to check that whether how I teaches to a student, just what he need to do is check the student copy. Bus. If the notes are properly mannered, if they are writing properly, if they are having stress properly, it means teacher is strict and he is good in teaching. Okay. But if I'm not keeping a proper eye on you, if you are doing something wrong or not, whether maintaining your notes or not. So in that case, what is going to happen is that nobody is going to tell you or nobody is going to blame you that you are. Simply blame on teacher. That's why, because I'm not strict. I'm not having a proper eye on you, whether you are doing something correct or not. So after the class, you need to send the notes. Okay. Everybody has to send the note, whether you are writing or not. Okay. So let's move further. Non-metals, when react with oxygen, they form non-metallic oxides. Okay. And non-metallic oxides are generally basic in nature. They are, acidic in nature. Non-metals, generally, you have seen that we have studied in the previous class that metals oxides are generally basic. Metal oxides are generally basic in nature, but sometimes they form acidic oxides also. Okay. Like in the previous class, we have discussed that sometimes the ZNO, when react with H2SO4, it forms ZnSO4 plus water. But when ZNO react with NaOH, it forms Na2ZNO2 plus water. So here it is acting, it is base, so here it is acting acid. Here it is acid, so it is acting as a base. Okay. So sometimes metal oxide can also act as acid and base, but non-metal oxide cannot act as acid and base. They generally they form non-metal oxides. Non-metal oxides are generally acidic in nature, but some oxides also show neutral behavior. Okay, but they never form acidic oxide, basic oxides. They are acidic, but they never form, like the non-metal form both acidic and basic, but non-metal do not form basic oxide. Got my point?
Yes, sir.
They generally form acidic oxide they are acidic in nature, but some are neutral also. Got it? Some are neutral also. Okay, on Friday we're going to have some test. We will we'll tell you that on Friday we are going to have some test. Mostly we're going to have the test up to metals and non-metals, except the topic that is occurrence of metal or purification of metals, or we can simply say that topic is metallurgy, the purification of ores, that portion of this metal. Up to the metals and non-metals, the chemical properties of metals, the physical properties of metals, the bond between metals and non-metals. Okay, that is going to have the test on Friday. Got it?
Yes,
Beta?
sir.
So let it, they never form basic oxides. Acidic oxides of non-metals. This is the acidic oxides. And neutral oxide of non-metals are this one, carbon monoxide, N2O and NO. Note it down, please. When you're done, let me know. Done?
Done, sir.
Okay.
Yes, sir.
So you see that here it is non-metal oxide, non-metal oxides, as sulfur dioxide, or sulfur trioxide or carbon dioxide. These are non-metallic oxides. So they are acidic in nature. You see, these are acidic in nature. So if these are added to water, they form acids. Okay, just like for example, SO2 when react with water, it is forming H2SO3. Got it? H2SO3. Keeping in mind that if the gas is SO2, then here we will have SO3. If the gas is SO3, then we will have here H2SO4. If the carbon dioxide is CO2, then we will have CO3 here. Got it?
Yes, sir.
One oxygen atom from the water will added. Okay. Note it down.
Done, sir.
Then should I move to the next? Okay. Every other students have done. Nobody is going
Yes,
to
sir.
tell me that sir, I have not noted because you skipped the slide and this one. Nobody, I'm not going to listen anything regarding to the notes. You have to prepare each and everything properly. Okay. There's a loose dot structure of some elements that we have discussed. Okay. Now we have studied. Now there are some properties of, we are just going to discuss the properties of metals and non-metals. Yes. Okay. So we are just discussing the chemical properties. Sorry, metals and non-metals chemical properties have done. Now the topic is why do ionic compounds, I have given you this one in the homework. Why do ionic compound, means the properties of ionic compound, topic is properties of ionic compound. But can you tell me what are ionic compounds? Can anybody hear?
Sir, no idea.
No idea. The compound that is formed between metals and non-metals. Generally, ionic compounds, the compounds that is formed between positively charged ions, positively and negatively charged, positively and negatively charged ions. Got it? Got it?
Yes, sir.
The properties of ionic compounds, the compound that is formed between positively and negatively charged ions. For example, if I'm having MgO, is it an ionic compound? Yes, it is an ionic compound. Why? Because it is Mg2 positive and this is O minus 2. Okay.
Yes, sir.
Okay. So this is an ionic compound. Similarly, if I'm having or the correct definition, the better definition is the compound formed by complete transfer and complete gain of electron. The compound formed by complete transfer and complete gain of electron. Or other definition you can write, or the compound formed between metals and non-metals. Okay, exception there, but there is an exception. Except the compound of ammonium ion. The compound of ammonium ions. Got it? Write it fast, beta. Done?
Sir, done.
Yes, sir. Done.
Jobita, done?
Yes, sir.
Okay. So what are the characteristics of ionic compound? Then only two types of questions comes. I'm just going to write the answers. That why ionic compounds. I have given you these questions in the homework. Have you done that one? have generally high melting and boiling point. Melting and boiling point. Note it down. Why any compounds have generally high melting and boiling point? So why they have? Can anybody in the class can tell me why they have high melting and boiling points?
Sir, because the bond is very, very strong.
Yes, the bond is electrostatic bond, and electrostatic bond is the strongest bond in the chemistry. Okay, it is the strongest bond in which the ions are tightly bonded together. They are not free to move. They are hold together very, very tightly. So the strong force of attraction for this, to overcome this strong force of attraction, to move these ions apart, we need to apply a very large amount of energy. Okay, got it?
Yes,
Got
sir.
it? So if I'm saying that, I'm writing that ionic compounds, ionic in ionic compounds, in ionic compounds, in ionic compounds, ions are tightly bounded together with a strong force of attraction. Ions in ionic compounds, ions are tightly bonded together with a strong force of attraction. Okay? Due to positive and negative charge. Here, electrostatic force. Okay, electrostatic force. So इसका आगे लिखेंगे. That's why a large. That's why a large amount of energy is being required to overcome this force. To overcome this force. Got it?
So can you please repeat once?
Yes, ionic compounds are tightly bonded together with a strong force of attraction due to this, with a strong force of attraction due to or between. Okay, positive and negatively charged electrostatic force, we call them. Okay, that's why a large amount of energy is being required to overcome this force of attraction. Okay.
Yes, sir.
Okay, that's why they have resulting in high melting, resulting in high melting and boiling point. Got it? Please copy this.
Noted, sir.
Done?
Done, sir.
Yes, sir. Done.
Okay. Let's move to the next question. Similar type of questions are it comes in the examination. Why do ionic compounds are able to conduct electricity in molten or aqueous state? Only. Yes, it may also come that why do ionic compounds, okay, students are leaving. So it may also come that why do some ionic compounds only conduct electricity in aqueous or molten state? Or it may, the same questions can also be arises that why do ionic compound do not conduct electricity in solid state? Tell me, beta. Is Shirish is in the class? Tell me, is there anyone who can answer this question? Actually, they are bonded together with a strong force of attraction. For example, this is Cl minus ion. 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 Okay. And this is sodium ion. In between it is Na. Then again sodium ion Na. Okay. Then Cl minus ion. Cl minus ion. So they are tightly bonded together with a strong force of attractions. And they are and that's why they are not able to move freely. They are not able to. Still, they are having charge, but they are not able to move freely. Got it? Because they are tightly bonded together. They are tightly bonded together, so they are not going to move free. They are bonded together. But in aqueous or in molten state, when you heat it such that their force of attraction become loose and they are in molten state, what would happen? They start moving freely. They start moving freely anywhere. Okay. And similarly, when it is added, when NaCl is added to water, NaCl when added to water, it will becomes Na positive and Cl minus ions. I mean, it breaks into ions. So in this simple word, we can say that ionic compounds are able to conduct electricity in aqueous or molten state just because. Why they are able to conduct electricity? Tell me. So you can write it. The in ionic compounds, ions are tightly bonded together, and they are not free to in solid state. That's why ionic compounds are bad conductor of electricity in solid state. But in aqueous or molten state, these are free. These means ions. Oh, what had just happened? अरे यार ये पूरा हट गया. But in aqueous or in molten state, ions are dissociated. Ions are dissociated. Okay, ions are dissociated. And what would happen? But in aqueous or in molten state, ions are dissociated. What would happen then? If ions are dissociated, means they are being broken. This, for example, this is NaCl. It when it got dissociated, it formed Na positive and Cl minus ion. And this Cl minus ion can go anywhere, and this Na positive ion can go anywhere. So, but in aqueous or in molten states, ions are dissociated, and they are able to conduct electricity. They are able to conduct electricity. Put it down. Put it down, beta. Fast.
Done, sir.
Sir, done.
Is there anyone?
Done, sir.
Yeah. Why you leave the class, Abhi?
Sir, I got
It-
disconnected because my battery was low.
Okay. So is it okay, dear students? Now you understood? The next topic of this class, we have done this metals and non-metals, every portion of this metals and non-metals. Any question, if you are having notes properly that we have studied in the class, then no question will be there in the of regarding the non-metals, the properties of non-metals and metals. There will be no such question that is going to come in your examination that you, and the answer for that question you don't know. So that, okay, every question you need to answers, and you can easily answer from this portion that we have studied. Moreover, in the next class, what we're going to do, we're going to study metallurgy topic. Okay, what we're going to study, let me explain you metallurgy. Every class of this chapter is very important. Okay, so let me explain you what we're going to study. This topic we're going to study in the class. Let me explain you. This is metallurgy slides. What we're going to discuss in the class, that what is actually metallurgy, and we're going to discuss that what is ore. Okay, what is an ore? What are minerals? We're going to discuss. Okay, what are ores? What are minerals? Some important method of separations like enrichment of ores. We're going to discuss. Okay, the gravity separations, the flotation method, a little bit about this one. We're not going to do this one in detail because this portion is not being asked more thoroughly in the examination. Like magnetic separation, I mean different techniques how to separate the ores. And moreover, other topic is calcination, roasting, reduction of ores. That means this is the means what we're going to study, that how does metal occurs and what are the steps that we used when we get a metals from the earth crust, and what are the metals that, for example, sometimes we enrich the ore, sometimes we sometimes we purify the ores, sometimes we do some different methods. Okay, during that one, so we're going to discuss this one. Okay, got it? So
Yes, sir.
write down the topic for the next class, that is metallurgy. Let's please note it down. Beta. Let's do some question regarding to this one. We have 5 to 10 minutes right now, so let's do the question regarding to the topic that we have studied. Have you studied about the aquaregia? I have not yet. Right, one more topic, but aquaregia we have not studied. What is aquaregia? Is there anyone who can explain me what is aquaregia?
It is a mixture of hydrochloric acid as well as nitric acid in ratio 3:1.
Yes, you're very good, beta. Okay, so if I'm saying that what is aquaregia? So what is aquaregia? Aquaregia is a mixture. Note it down to the students who have not noted. It is the mixture. It is the mixture of
That
concentrated
is used to make
HCl.
gold.
Aquaregia. It is also called royal water. It is also called royal water. So it is the mixture. It is the mixture of concentrated HCl and concentrated HNO3. HCl is hydrochloric acid. Hydrochloric. HCl is hydrochloric acid. And HNO3 is nitric acid. So what you need to know is here is that the ratio for HCl is to HNO3 in nitric acid is 3:1. 3:1. Sometimes it is being written like this way. HNO3 is to HCl. That will be 1:3. Okay, so you need to keep in mind that if we have HNO3 ratio is 1 and that of HCl is 3. Got it? And it is used for what's the function of? It is used for dissolution of gold and silver. Okay, it is used for dissolution gold and silver. Okay, got it? In ancient times, when we have to dissolve the gold and silver, we need to done.
Done, sir.
Done.
Is there anything? Is there anything left behind? Have you noted each and everything? Okay. So we were just discussing some questions. Let's have some 1 or 2 questions. I'm going to send you this whole chapter from the NCERT examiner, and that book is very important for the examination point of view. Okay, so you have to practice it thoroughly. So I'm going to send you this one. Wait a minute. Metals and non-metals. So these are the conceptual questions that are going to come in examinations. Okay, for example, if we have metals, which are the following is not, which property is not shown by metals? Tell me. Question number 1.
Dullness is not shown
Okay.
by metals.
Okay, the ability of metals to be drawn into wire is known as
Ductility.
ductility, and that malleability is called
Malleability is the ability to beat them into thin sheets.
very good, very good. And third one, the aluminium is used for making cooking utensils. Which of the following properties of aluminiums are responsible for the same? Aluminium
1
is used
and
for
4.
1 and 4, good thermal conductivity, and 4, high melting points. And ductility, tungsten is also ductile in nature. Okay, so beta, you need to discuss this one. Okay, I will going to send you. You have to. This is the homework for you. Okay, this, for example, this question, the composition of aquaregia. Okay, so this is the homework for you. Friday only the portion that is uh, regarding or related to the purifications topics, okay, that we have not studied. We are not going to ask you the question from that topic, but I'm going to send you this whole as a whole, and you have to prepare this one. Okay. Okay. Got it?
Yes, sir.
So the question will come from this topic, and we'll have some topics that we'll have studied in the class. So please try to do this one. For example, it's question number 42, 41, okay, 43. You have to do this one. Okay. So when you start doing this, you will be perfect. These are conceptual questions are very important for your concept. If you have done these questions, means you have finished this chapter thoroughly, and there will be no such questions. So we'll discuss this one, but you have to do this one. So till Friday, if you are having any doubt regarding to this one, but on Friday we're going to have this test. Okay. So in the next class, it might be possible that we're going to have this chemistry class, okay, or maybe biology class, but it will be. But you need to prepare. If you have any doubt, we will discuss this one. But you need to prepare these questions only. Okay, each and every question you need to practice. Okay. Okay, only those questions or those topics. I will mention you the top and the numbers. I will give you day by day. I'm not to say that you have to prepare this in one day. I will give you 10 to 20 questions to practice in one day. The second day, I will give you again 10 to 20 questions, and third day, I can give you 10 to 20 questions. So it will be okay. Till then, you have all practice that all the questions regarding to the topic that is going to come in the test. Okay. Okay. Is that
Yes,
clear?
sir. Yes,
So
sir.
that's all for today. We'll meet you next video. Okay. If the student may leave, okay. Samsung. What's your name, beta? Samsung GE9 in this one. Hello. Hello, beta. Is I'm audible to you? Hello. Hello, beta. Is I'm audible?